Hello, my name is Joel McGlynn. I'm a program manager in the aftermarket business development team at Textron Aviation. This presentation will focus on NextGen. NextGen is a very broad term that applies to a lot of technologies that are on the horizon for upgrading the airspace systems around the world. But this presentation will focus upon a few specific technologies that particularly are of interest to operators now because there are mandates associated with them on the horizon. They're the nearer term key technologies that a lot of us have our eyes on. We'll focus on how Textron Aviation is preparing our Cessna, Beechcraft, and Hawker models for these key technologies: TCAS 2 version 7.1, Adsb out, SBAS LPV, FANS 1A over the North Atlantic, and we'll wrap up the discussion with performance-based navigation. Now, TCAS 2 version 7.1 technically isn't a next-gen technology per se, but it is a surveillance technology that has mandates associated with it in the near future, and so it is appropriate to talk about it in this context. The first major improvement with version 7.1 for TCAS 2 is resolution advisory reversal capability. This allows the TCAS systems onboard two aircraft that are involved in a resolution advisory situation to coordinate in such a way that if the crew of one of the aircraft does not comply with the TCAS directive to climb or descend, the two boxes can coordinate and the other crew that is complying can then be issued a directive to reverse what they were originally told to do. This was a result of an accident that happened over southern Germany in 2002, in which two airliner-class aircraft collided at 34,000 feet. Very tragic accident, and this change to version 7.1 was developed in response to that situation. Another change with TCAS 2 7.1 is the replacement of the adjust vertical speed adjust call-out with the level off call-out. It's less ambiguous, whereas the crews with the adjust vertical speed adjust were required to look at their PFD and determine how much to adjust their vertical speed to avoid a conflict with other traffic in a climb or descent situation. Now it simply tells them to level off, which is much clearer, much easier to comply with in a tense situation. The regulatory situation with regard to TCAS 2 involves a retrofit date of December 1st of 2015 in Europe. At that point, all aircraft with TCAS 2 on board will be required to have version 7.1 for operations in Europe. This includes both aircraft that are based in Europe as well as transient aircraft. The FAA has recommended TCAS 2 version 7.1 because of its safety benefits. However, there is no mandate in the United States at this time. There is an ICAO standard in ICAO Annex 10 that states that aircraft should have this capability by the 1st of January 2017. That's the retrofit date. The forward fit date has already passed with regard to the ICAO standards. Now, of course, ICAO standards are not regulations. They're standards that individual states then adopt in order to make them regulations. Because of the dates that are out there in the standards, though, I do expect that additional countries will likely adopt rules for the adoption of version 7.1. So if you operate internationally, be aware of that. Now, on citation aircraft that are equipped with Proline 21, including the CJ series, Encore Plus, and the XLS Plus, service bulletins are already available for this. Cessna did also install the TCAS 2000 system from ACSS on a number of aircraft, including the XL series aircraft, Sovereign aircraft, and Citation 10s. And there are bulletins already available for those as well. Now, one point to note is that with this system, there was an airworthiness directive issued against it in 2012, and the compliance period for that airworthiness directive just ended in March of this year. So if your aircraft has a TCAS 2000 system on board, and if you have not yet complied with the terms of that airworthiness directive, it's important that you do so immediately. One path for doing that is to upgrade to version 7.1. There is another path. You can simply improve your version 7.0. But if you do go ahead and upgrade to 7.1, that will take care of the Airworthiness Directive compliance. The program that we have in work right now at Cessna, and which will be completed soon, is for the CAS 67 system from Honeywell. It's the Bendix King Honeywell system, and that was installed on a number of different Citation models over the years, and the bulletins for those are scheduled for release this summer. We're working very diligently on those right now. Now on the Beechcraft side, the Collins TCAS 4000 equipped King Airs, as well as the Premier 1 and 1A and the Beechjet 400A, all have STCs available for upgrading to 7.1. On Hawker aircraft equipped with TCAS 4000, similarly, the 400XP, 750, some of the 800XPs, and then the 850 and 900XP all have an STC or kit upgrade path available. The only Hawker airplane that had the ACSS system installed was the 4000. The service bulletin for that does also address the AD, similar to what we mentioned on the Citation side. Now, if you upgrade to version 7.1, there are typically a couple of different upgrade methods available. You can upgrade your existing unit. It does take longer to do that. Depending on the supplier, it can take up to 2 weeks to get your unit sent out to the supplier and then upgraded and then returned. So if you choose that path, it would be advantageous to do so when you have other maintenance scheduled. You can pay an additional fee for an expedited service, which cuts the time down to about a week, but as I said, there are some fees associated with doing that. If you have even less time available, then you can do an exchange typically, and that can take just 1 day to get your airplane in and out. However, there is a substantial fee that applies for doing that typically, and it's also necessary to prearrange so that a unit is waiting and ready for installation on your airplane when you take it into the service center. Now, for the ACSS system only, the TCAS 2000 system, Textron Aviation does have the capability of upgrading that system on the aircraft itself. We have some data loaders positioned at some of our service centers, and we can go ahead and do that upgrade on wing. The software loading process requires less than an hour, so you could be in and out of the service center literally in a few hours. But you'll need to prearrange that, of course, too, because we need to make sure we have the software ready and that the data loader is in place at the particular service center where you might bring your airplane. Now we'll switch to the topic of Adsb out. Of course, the major change here, this is foundational to NextGen, and the major change here is the shift away from radar-based air traffic control surveillance to GPS-based broadcasting of an aircraft's own position for providing surveillance information for air traffic control. It's more efficient, it's more accurate, and it is the foundation of NextGen in terms of surveillance. Major deadlines for Adsb out include, of course, the United States deadline of January 1st, 2020. That's both the forward and retrofit date in the United States. Europe had a forward fit date of January 2015, and the retrofit date was in December of 2017. They have moved those dates out. It's not official in the regulations yet, but the information has been disseminated that they do intend to move those dates to 2016 and 2020 respectively. So fortunately, there has been some relief there to give the industry more time to respond and equip the aircraft as needed. In Australia, on the other hand, and along some routes in the Southeast Asia Pacific area, aircraft operators are already required to have Adsb capability from flight level 290 and above. There has been a waiver process in Australia for some of the aircraft based there, but those waivers are going to be timing out later this year. So there is a strong need for Adsb capability in that part of the world. In addition, in Australia's roadmap for Adsb implementation, they've specified that the 4th of February 2016 will be the date by which all aircraft operating IFR in classes A, C, and E airspace will require Adsb, which of course means that for business aircraft, turboprops, business jets, there's going to be no alternative. ADS-B will be required. For Citation aircraft, we have a program for the Mustang now in place. The intention there is to release a service bulletin the second quarter of 2016. Again, that's for the G1000 equipped Mustang. For Collins Proline 21 aircraft, we have several service bulletins in the works for ADS-B out. CJ4 has a bulletin scheduled for this quarter, the second quarter of this year. The XLS Plus service bulletin is scheduled for the third quarter of this year, and then the CJ1 Plus, 2 Plus, and 3 service bulletins are targeted for release in the fourth quarter of this year. Now, if you have a CJ1 or CJ2, not the Plus versions, with either the Bendix King CNI 5000 radio stack installed or a Garmin GNS 53430 stack, we do have an STC upgrade path available. It's not a service bulletin. You won't find it in our service bulletin listings, but we do have an STC path available. It's been installed on a few aircraft in the United States already. It involves installing typically Garmin GTN type touchscreen nav comms in lieu of the CNI 5000 or the GNS 53430s, and also installing Garmin GTX transponders. So there is a path for doing that. We have not yet validated that STC in any other countries that I'm aware of, but we could certainly pursue that if there's interest in other parts of the world. Now on the Sovereign with the Epic system, the service bulletin for that is scheduled the third quarter of this year. And we also have service bulletins scheduled for the Ultra, the Encore, the XL, and the XLS that have universal FMSs on board. That's the fourth quarter of this year is the target for that. A lot of work has already been completed at Honeywell and Cessna for the Legacy Citation 10. We were intending to have ADS-B done at the beginning of last year for this platform. However, there was an issue discovered with the Honeywell software at the last minute. It involved an incompatibility with the existing enhanced surveillance situation in Europe, and so Honeywell had to go back and fix that in their software. They are actively working that now. We just received some hardware for testing, and the service bulletin target for that is the end of 2015. Now, if you have a G1000 equipped Caravan, we have a service bulletin in the works for that, anticipated at the end of this year. On the Beechcraft side, for Collins Proline 21 equipped King Airs in particular, the service bulletins for those are scheduled for the third quarter of this year. We have a new program that we're just getting underway for the Premier 1 and 1A, with service bulletins for those targeted for the second quarter of 2016. And for the Beechjet 400A, similarly, new program we have underway for getting ADS-B done for that platform, again, in the beginning of next year, second quarter. For Hawker Proline 21 aircraft, the Hawker 750, some of the 800XP aircraft, and then the 850 and 900 XPs, we anticipate service bulletins in the fourth quarter of 2015 for those. And similar to the Beechjet 400A, for the Hawker 400 XP, the service bulletin there for ADS-B is scheduled for the second quarter of next year. So we'll have a busy start to 2016 with some of those models. Now you may be aware that SBAS type GPS receivers are required to support ADS-B capability. SBAS stands for Space-Based Augmentation System. The United States WAAS system, or Wide Area Augmentation System, is an example of that, as is the EGNOS system in Europe, which stands for European Geostationary Navigation Overlay Service. These are systems that sharpen up the GPS signal and correct for regional atmospheric variations. However, the requirement to have SBAS-type GPS receivers for ADS-B is not an accuracy issue. It has to do with the fact that the newer generation of SBAS receivers also meet specific ADS-B technical requirements that were developed in parallel. It's not cost-effective for the avionics manufacturers to go back and rework their existing GPS receivers. Instead, they've developed a newer generation of receivers to meet those ADS-B technical requirements. Now, Localizer performance with vertical approach capability, vertical guidance approach capability, is not required for Adsb either, but it is useful in its own right. This map shows the United States situation with respect to LPV approaches. As of the beginning of April, there were over 3,500 LPV approaches serving over 1,700 airports in the United States. Compare that with approximately 1,300 ILS approaches, and you'll understand the magnitude of this trend and how many of these approaches are being developed in the United States. Canada is covered by the United States WAAS signal as well, and you can see there a map that shows approaches that are being developed in Canada or have already been developed at a number of airports in various places in Canada. Similarly, in Europe, this map shows airports that already have LPV procedures at them. Those are denoted by the green aircraft symbols, and the yellow aircraft symbols denote airports for which LPV procedures are planned in the future. There are quite a few approaches already in Europe of this kind as well. So it's useful technology to have in its own right. Now, with regard to SBAS LPV capability on the citations, the Collins Proline 21 aircraft have been in a good position for quite some time. Many of those aircraft left the factory with that capability standard, but earlier on in some of the production runs for these models, we didn't necessarily always have it available yet, and so there are bulletins available for those models there with Proline 21. Honeywell Primus 1000 equipped aircraft, including the Bravo, the Ultra, the Encore, the XL, and the XLS, also have service bulletins already available. However, the one caveat there is those bulletins are applicable to those models that have universal FMSs on board. The Sovereign has a service bulletin available for the Primus Epic system, as does the Citation 10. However, the Citation 10 bulletin is still in work. The original bulletin has been released. There will be revisions to it. The original revision allows U.S. registered aircraft that do not have winglets to have what we call NZ 6.1, which is the software level in the FMS, installed. However, we are working on getting the aircraft registered in Europe also included in that bulletin by the end of this year. But in both of those situations, those are aircraft without winglets. And the reason for that is that Winglet Technology owns the STC for the winglets themselves, and therefore they are pursuing the certification of NZ 6.1 WAAS LPV capability for those aircraft. They have to do some work with the TOLD database in particular. We're doing a lot of the testing for the approach capability, of course, but they have to complete the certification with their takeoff and landing database, which, for those of you who have winglets, know that that had to be taken out of the airplane when you put your winglets on originally, and we're working with Winglet Technology to regain that capability for winglet-equipped Citation 10s. On the Beechcraft side, the King Airs have STCs available for them with those model types. And we do have a new program now for the Premier 1 in parallel with our Adsb effort. We're working a service bulletin for release in the second quarter of next year for SBAS LPV capability on the Premier 1. There is already a bulletin available for the 1A. And the Beechjet 400A does have an STC available. However, one caveat there is that currently it's only available to operators in the U.S. We are starting the work now to get that validated through EASA. So we're trying to do that. But right now, that's only available in the U.S. for the 400A. There are bulletins available for the Hawker models, the 987 models as we call them, 750, some of the 800 XPs, and then the 850 and 900 XPs do have bulletins. The Proline 4 equipped 400 XP, similar to the Beechjet 400A, does have an STC available, again, only available in the United States as of this time. We're working to try to validate that elsewhere. Now, we do have a program in place for those Hawker 800 XPs that were equipped with the Honeywell SPZ 8000 and NZ 2000 systems. The SPZ 8000 being the EFIS system and the NZ 2000 being the FMS. There was already a version of 6.1 WAS LPV software available for that platform. However, there were issues with it. There were some nuisance issues in that original software load. Honeywell has since addressed that with a new software load that we are currently certifying, and we expect to have that done yet in the second quarter of this year. So if you have that particular platform of 800XP, you can upgrade if you've already installed the first STC, or you can just install the entire package if you've never had LPV on your airplane. The Hawker 4000 does also have an upgrade service bulletin available, and the caveat there is that the aircraft is required to have Epic Load 20 software as a prerequisite. Typical installation time for an SBAS LPV upgrade is about 2.5 weeks. It requires upgrading the GPS receivers, of course, to include SBAS capability. New antennas have to go on the airplane, and also you have to update the FMS software. So there's quite a bit to it. Typically takes a little over 2 weeks. In some cases, new FMSs may be required. If you have a legacy FMS, such as, for example, the GNS XLS is an older FMS for which there is no LPV upgrade path planned. So in cases like that, you may have to install a universal FMS, for example, or some newer FMS that we have available that can take care of the LPV capability. There's a considerable amount of press these days about standalone Adsb solutions. If you read aviation periodicals or if you go to trade shows, you'll see a lot of suppliers are now working on standalone Adsb solutions. And by standalone, we mean a third transponder. In addition to the 2 transponders that are already on the aircraft, there's a third transponder not heavily integrated with the existing avionics platform. And in most cases, these third transponders will have their own associated SBAS type GPS receiver. The idea being that the crew can turn off the main transponders on the airplane, turn on the third one where ADSB is required, and since it has its own SBAS receiver that meets the requirements, all the correct information will be downlinked to ATC. In many cases, these are considered to be less expensive solutions. However, there are challenges associated with those. If a particular aircraft has a significantly integrated avionics platform, as many of the newer aircraft have, it may not be possible to install this type of receiver because, for example, if the crew turns off the main transponders on the aircraft and switches on a third independent transponder, it may generate a crew alerting system or CAS message that says, for example, transponder standby. Typically that would be an amber CAS message, and it's not considered certifiable for the crew to have that CAS message constantly displayed because it could be misleading. They may think, oh, we just ignore that message, and they may fail to turn on their other transponder, for example. So it's not considered to be a good situation to do that. In addition, standalone ADSB solutions do not offer SBAS LPV capability, typically. They're not integrated with the existing avionics for doing this type of approach. So that's something else to keep in mind with this kind of solution. It may be the appropriate solution for certain platforms, and we may pursue some of these installations where appropriate on specific models. We are looking at some of that. However, our current focus is definitely primarily upon integrated solutions on integrated platforms. We believe strongly in including LPV capability wherever we can because aircraft that are equipped with LPV capability are better oriented to the current and future airspace environment. As ILSs become increasingly expensive to maintain, this type of approach will begin to become more and more prevalent. And we just believe that most operators are going to either strongly desire or require this capability in the future, possibly even this individual. Now, a number of our customers have asked us about FANS 1A capability in the North Atlantic. Those of you who fly in the North Atlantic region are familiar with these phases, 2 of which are already passed. We have Phase 1 and 2A already in place. Today, if you fly across the North Atlantic, you're required to have FANS 1A capability if you fly on any of the North Atlantic tracks in the organized track system from flight level 350 to 390. The two highlighted phases on this slide are the phases that are yet in the future. Phase 2B is scheduled for December of 2017, at which point all aircraft operating throughout the North Atlantic track region from flight level 350 to 390 will be required to have FANS 1A capability. And then Phase 2C comes into effect in January of 2020, at which point the altitudes will change. Now it will be from flight level 290 and above. The key point to remember is that this is in the North Atlantic track region. There is a region further north where it won't be required. I'll show you a slide on that here in a moment. For our new citation aircraft, the longer range citation aircraft that have G5000 avionics installed, that includes the Citation 10 Plus, the Sovereign Plus, and the Latitude, Garmin is working on a FANS 1A solution for those platforms. It will be an option, and it will be available. We expect it to be available in approximately the 2016 timeframe for those G5000 equipped citations. However, we do not currently have any aftermarket solutions in active development for FANS 1A. And the reason for that is that the business case is unclear. It's quite expensive to install this type of system in an existing aircraft platform. There are a lot of changes that are required. The FMS software has to change. There has to be a data link system on the airplane that's capable of doing FANS communication. And there also has to be a SATCOM on board the airplane as the path for sending the data via satellite to ATC, for example, when you're in an oceanic environment. So it is quite an expensive proposition, could cost upwards of $300,000, maybe even up to $500,000 or more to integrate this type of system into an existing avionics platform. In addition to that, this map shows a region in magenta where FANS 1A is not foreseen to be a requirement because it's close enough to land areas that it will be within the reach of radar systems or Adsb systems, which will enable air traffic control to know the precise locations of those aircraft. So for that reason, this area here is anticipated to have an exemption for aircraft so that aircraft won't have to have FANS 1A. For that reason, again, as I've said, we have not pursued and are not currently pursuing this on existing platforms. If you fly the North Atlantic regularly in an existing Citation or Hawker aircraft, for example, let us know if you operate there enough that you think you'd want to go to that much expense to be able to do that. But typically aircraft with the range of the aircraft we have produced will usually fly those northerly routes anyway. So let us know. We're interested in hearing from you, but as of this time we have no programs in active development for the aftermarket. I'd like to wrap up this presentation with a discussion of performance-based navigation. This, of course, has to do with the navigation aspects of the NextGen airspace environment. So what is it? Performance-based navigation, in the most simple, concise definition I can give you, is area navigation, or RNAV, which is typically based on GPS, with specific, consistently defined lateral navigation accuracy requirements for a given route or approach. This diagram, produced by the FAA, depicts the transition from traditional navigation, which required flying from NavAid to NavAid, ground-based NavAid to ground-based NavAid, to RNAV, which we see in heavy use today, and ultimately to RNP, which is starting to come into existence now. RNP stands for Required Navigation Performance. You can see in this transition an aircraft operating from ground-based NavAid to ground-based NavAid, or in this case VOR to VOR. You can see that accuracy as you get further from the VOR is decreased. So airspace designers had to take that into account when they chose their spacing between airways, for example. As we moved into the RNAV world, now we're no longer constrained by ground-based NavAid location. We can now have GPS-defined waypoints. So there's a lot more flexibility now, and it's more accurate. So approach and airspace designers have more flexibility in terms of increasing airspace efficiency. Where all of this is headed is into the world of required navigation performance, which I'll define in a moment. But the world of RNP allows even greater accuracy, and in some cases it involves some new definitions for paths in procedures. For example, you can have a curved path now, and because it's based on area navigation, we can have a high degree of confidence that the aircraft will keep to a specific curved path, sometimes called a radius to fixed leg. So that adds some flexibility and, again, some increased accuracy, which again gives airway designers more flexibility still in optimizing the use of airspace. Now, there are two different types of navigation specification that you'll typically see in the context of performance-based navigation. Typically, you'll see either RNAV or RNP followed by a number. For example, you might see RNAV1, which requires that the aircraft have a total system error of less than or equal to 1 nautical mile, that's where the 1 comes from, 95% of the time. RNP1 is a similar navigation specification. The only difference is that RNP1 requires that the aircraft have onboard accuracy monitoring and alerting, so that if the airplane traverses outside that plus or minus 1 nautical mile in either direction laterally, the system, the avionics, will alert the crew that that has occurred so that they can take action. That's the difference between those two types of specification. The challenge for Textron Aviation is that as more and more of these types of navigation specifications, such as RNAV1 and RNP approach specifications, come into existence, the challenge for us is to keep our existing aircraft as capable as possible to fly those types of procedures. And the challenge associated with that has to do with the fact that our approved flight manuals are produced at the time of aircraft certification. When we type certify a new aircraft design, we will look at that aircraft design, check all of the regulatory guidance material out there that pertains to certification to see what are the different types of navigation specifications that this aircraft design will meet. And then we'll state those in either the AFM itself, in the limitations section, or in a approved flight manual supplement. In some cases, we'll put it in the FMS supplement, typically. So here, for example, you see RNP4. That's one that you may all be familiar with in your AFM. You probably find that one there already. RNP10 is an oceanic designation. RNAV1 is a little bit newer definition of a navigation specification. The challenge for us is also that navigation-related terminology and regulatory guidance material change over time. So whereas something formerly may have been called RNP or RNAV with something after it, now it may have changed to a new RNAV designation. For example, on the Citation 10 Plus, a recently certified citation model, we've included RNAV2 and RNAV1 as available navigation specifications. Individual operators will still have to obtain whatever letters of authorization or LOAs are required to conduct those type of procedures, if that's required by their local authority. But we call it out as a capability that the airplane has, and we've tested it for that. We base that, in this case, upon Advisory Circular 90-100A. That's an FAA advisory circular pertaining to certification, and those two navigation specifications are defined there. However, if we go back in time and look at the legacy Citation 10, there was an earlier, now outdated navigation specification underlined there as U.S. Type A and Type B RNAV departure procedures and arrivals. Well, we don't call them Type A and Type B anymore. The new ICAO definition for Type B, for example, is RNAV1. But operators don't necessarily know that, and so we have a job to do to make sure that we keep these specifications as current as possible in our flight manuals. Another example of how regulatory material can change and require us to go back and do more evaluation is given here in this example, the Sovereign Plus approved flight manual. When we produced the Sovereign Plus, again a recent model, EASA had a document called AMC 20-27. It's still in existence. It has to do with barometric VNAV type approaches. And so we called it out. We looked at that document while we did our certification and agreed, yes, it meets all these requirements called out in AMC 2027, and therefore we stated that it met those requirements. More recently, we certified the CJ3 Plus, and in the time between when we certified the Sovereign Plus and the CJ3 Plus, EASA came out with another document called AMC 20-28. That one has to do with the European definition of LPV approaches. Well, we called it out in the CJ3 Plus AFM, but we don't yet have it called out in the Sovereign Plus AFM. So we're going to have to go back and evaluate the Sovereign Plus against AMC 2028 and then include that in the list of documents that support the navigation specifications for the Sovereign Plus. So there's quite a bit of work to be done. It's not a small task. We have the AFM changes that are required, but we also have to continuously keep our eyes open to reevaluate our various models against the ever-developing guidance material worldwide. And again, our goal is to keep you as the operator flying as many of these types of procedures as your aircraft is indeed capable of. Our intent is to get ahead of all of this and to stay ahead of it. It's going to be more and more challenging as more and more of these types of RNP type procedures become available in various parts of the world. But we are working on trying to be proactive about that. In the meantime, let us know if you see restrictions. For example, if you run into an arrival procedure, for example, that requires a certain navigation specification, such as RNP1 or something. Let us know if that's becoming a hindrance to your operations. In the meantime, we may be able to issue you a letter or some kind of a statement. Depending on the situation, we can evaluate that on a case-by-case basis. So we want you to be operating where you need to operate. Let us know if you see this type of restriction in the meantime. All of this information on performance-based navigation is defined in the ICAO Performance-Based Navigation Manual, and the most recent issue of that was in 2013. It's quite a lengthy manual, so if you'd rather read something a bit shorter, we are in the final stages of producing a technology briefing for performance-based navigation. It gives actually more definition than I'm giving in this presentation, so if you want to read that, you can get a bit more background on some of the terminology and some of the concepts associated with performance-based navigation, as well as some tables at the end which will list out what the different capabilities are in our aircraft at the present time. And in some cases, we're hoping to be able to add to those capabilities given what's currently called out in the flight manuals. That technology briefing will join the other technology briefings that we already have available. Now these can be found on TextAv support, txtavsupport.com, as well as cessnasupport.com. And you can see if you go to any landing page for any citation model and you go to the right-hand lower corner, you can find the technology briefings. There you'll see the topics that I've talked about today included. There's a couple of others there as well. And we will be adding the new one for performance-based navigation in the near future. Similarly, if you're a Beechcraft customer, the global customer support page does have links to these same technology briefings. There is a placeholder already there for performance-based navigation, which should again be there very soon. That concludes the presentation on these key NextGen topics. We're sure you'll have questions, so please see your Textron Aviation field support representative, or you can call us as well into the call center teams, and you can talk to your aftermarket sales representative as well about these technologies. One point I would emphasize is that it is our intention to keep all of you operating to the maximum extent possible. Our intention is to have you covered with respect to these technologies as they become more and more prevalent. Thank you for your attention.